Cool, great. So let's jump into an exercise looking at how throughput is actually employed. First of all, again, like I say, this idea of throughput is really dealing with very modern industries where, again, like I highlight, that labor is no longer a big factor that way, where our focus really becomes, if you like, the key cost in terms of, in variable terms, is direct material. So, yeah, and I sort of highlight that the real variable costs are material. Here we are. So, again, just emphasizing, we're aiming to use a scarce resource, use the best we can of a scarce resource, or a scarce process, I guess, if you like, think of it that way. So here we are. We have two products. You might have seen this when you did limiting factors, maybe earlier on in your study career. Two products, selling price, here we are, 25.28. These are the individual material costs. Our key focus is purely on this area here, direct materials. So don't get carried away by them putting this in there. You'll see how this factors in later on. But the key point here is that we're interested, if you like, in the difference between selling price and material. So ultimately, the difference between these two is what we refer to as throughput. And don't get carried away with this as well, because we're not interested in profit per se. What we're interested in is, what is the throughput going through this bottlenecked resource or process that only has 48,000 hours available to it. This is ultimate demand. So the question here is, we know we don't have enough of this, because when we look at this, right, we have maximum units here, we have 20,000 times 2. When we have maximum units here, we have 10,000 times 1. So we have 40,000 here, and we have 10,000 here, making 50,000. Right? So that means that, and we only have 48,000, so this is a bottleneck. That's how we know the bottleneck. Now, the next question has to be, right, we have a couple of products going through these processes. Who should we make first? And we should make the one that gives us the highest throughput, if you like, per bottlenecked time. So, yes, I highlight this again. We sort of look at that. That's the contribution coming out here. So what we now see is, we see this is the throughput. This is the amount of time it takes to make a unit. Hours time it takes to make a unit. And so we can now work out what the throughput is per hour. We can see what the throughput is per hour. And the throughput per hour, if you like, here is 8.5 per bottlenecked hour, and here it's 8. So we have a greater throughput here, so we should make product X first. And that's what we do. We go ahead, it tells us there's a demand for 20,000 units of X, requiring 2 hours each. So we use, in effect, you're going to use up 20,000 times 2, right? And that's 40,000 hours. Leaving 8,000 hours left to make product Y. Right. So there you are. So we make all we can of product X because it's given us the highest throughput, if you like, per hour. So here I am working it out to 20,000 units of X times 17 is 340 plus 8,000 units at £8 of product Y, giving a total throughput of 404,000. So you can see here that ultimately you might be asked to find the profit, and then all I have to do now is just take away the fixed costs, which is what we know. Contribution minus fixed costs, right, give us profit, ultimately. So, yeah, I think that's kind of the key point there. I'm just sort of, again, just giving you some background theory here. The aim of throughput accounting is to maximize this measure of profitability whilst reducing the operating expenses and stopping money being tied up in inventory. And again, I just highlight this about being a bottleneck. And in the short term, we should aim to make the best use of this bottleneck, because it really doesn't matter what's going on with the idle time in the non-bottleneck resource. You know, there's nothing really happening there. The key point, the problem here is that we should aim to eliminate the bottleneck in the long run. There are some assumptions. The total variable the total variable cost in the short term is the purchase cost of raw materials, which I highlighted earlier on. Direct labor costs are not variable in the short term. You can see why this is only very much a short-term sort of way of thinking about things. You can't really think about it in the long term. It's not really applicable that way. Very much a short-term approach. Right. Before we do an exam question, I think we should finish off. Let's sort of look at this idea over here of when there is a bottlenecked resource. So we're still remember this exam is on performance management, and we're still trying to, if you like, measure throughput or efficiency and which products we should make. Right, we've sort of done it here when we said, throughput per factory hour. This is based on the bottlenecked resource, by the way. So we have a bottlenecked resource, if you like. When I say, we have a bottlenecked resource that we've just been talking about. So when we discuss, what's the return per factory hour, we're really saying, what's the throughput per unit divided by the product's time on that bottlenecked resource. We've just done that, right? Now, of course, we've just said if we're in the same factory and we have to do A, B, and C, I feel like I'm repeating myself, we can compare A, B, C, and D by looking at what the throughput is for each of these, each unit of A or whatever, based on its time on this bottlenecked resource. So that's one measure, if you like, of efficiency. And if, to be fair, if we're just in the one factory and that's all we're comparing, that's enough, really, ultimately. But as you can imagine, there is another sort of measure referred to as the cost per factory hour, and this sort of says what are the total factory costs, if you like, total factory costs driven by this resource in terms of hours. So if you like, what is the operational cost per hour? I'm almost absorbing all the factory costs based on hours, if you like. How are the hours driving, if you like, the overhead costs? And I'll discuss why this is important in a second, but this is a measure in itself. I mean, this is we do this anyway. We absorb overheads over hours, and then we sort of say each hour drives a certain amount of overhead. So this is, if you like, absorption costing at some level. It is absorption costing at some level, and this is an important cost to make, because then we can if hours truly is the driver of operational cost, we can then, if you like, look at measures to reduce this, if you like. And it's a measure, isn't it? It's about performance. It's an indicator, and we can look at that. But the key point here is this: what we ultimately want to make sure is that the revenue coming in per hour, as you can imagine, is greater than the cost per hour of a factory hour, ultimately, because in effect we're really comparing revenue minus cost. It's almost like a ratio of revenue to cost, right? And ultimately, if revenue is greater than cost, then you could argue that the product is worthwhile making, because the revenue per hour is greater than the cost per hour. The revenue coming from something per hour is greater than the cost generated by the hour in the hour. So that's kind of the key issue here. So the way we compare this, so the ratio that we have to compare this is referred to as a throughput accounting ratio. And that looks, if you like, at the return per factory hour divided by the cost per factory hour. Now, the cost per factory hour I highlight here it says the total factory cost is the fixed production cost, including labor. So if you're given sort of operating costs, know that they include labor already, if you're given all the costs. And you can add all that together to find the total cost and divide that by the factory hours that you're given, if you like. When I say the factory hours of the bottlenecked resource, because that's really the issue here, if you like. So the argument here is TPAR greater than 1 suggests that throughput exceeds operating costs, so the product should make a profit, and priority should be given to the products that give the greatest ratios, ultimately. And anything less than 1 suggests that the product is making a loss. The focus is very much on the short term, and again, operating expenses, yes, are largely fixed. But again, of course, businesses cannot operate purely on this sort of short-term approach. And we'll see. I think what we'll do is we'll stop now, and then in the next session we'll do a question, and then we'll discuss again the reason you need TPAR, why it's an important ratio. But we'll discuss that in the next session.